So, guys, today our topics are here. We'll discuss one by one. So, first we'll discuss the packet flow of LAN with the based on the use. We'll use here switch, and we'll discuss some functionalities of switch, how switch behavior, and we have here two types of switches. One is manageable switch, and another one is unmanageable switches. For those things we'll discuss. Apart from that, switch topics, whichever we have here, I'll give the overview like VLAN, STP, and apart from that, we have different topics also. We'll discuss those things, and then we'll move to with packet flow of same thing. We'll use here with example Telnet. Okay, example we'll use example. It's up to here. We'll see in this packet flow only at layer 1, layer 2, and layer 3. But with when we are using port number is here, it will be used. Port number is 23. Telnet port number is 23. So based on that, if you want to check the traffic of L4 also, we can check here. It means transport layer. And yesterday, what we discussed, overview of OSA model, right? OSA model, Open System Interconnection Model, we discussed. So, can anyone tell me how many layers on OSA model? Quick
7.
overview. Yes, those are
Transport, application, physical, presentation.
yes, application and presentation.
Physical
Yes,
layer.
quick overview. Presentation and session,
Section.
and then
Transport layer,
transport, then
network layer,
yes, network, then
Data.
data
physical
link
data.
layer,
Physical.
data link layer,
Yes, physical, then physical.
Physical
Final
layer.
is yes. So physical layer.
Session layer.
This session layer is there. You can check here. It's 7th layer and 6th one, and it's one 5th, and transport is 4, and network is here. The third one, and data link layer is second one, and physical
Second one.
layer is 1. So it's OSA model, and what is the difference between OSA model and TCP/IP model? What are the difference?
In there we only have like 3 of them.
Tell me.
OSI is the reference model and TCP/IP is the implementation model.
Good.
In TCP/IP model, we have 3 layers: core layer, distribution layer, and network layer.
So first we will finish TCP/IP model here. Here we have only 4 layers. These are the now compared to here application and presentation and session. These are the layer 7 and 6 and 5. These are the comes under application layer, and we have third layer is its transport layer is 4, and here we have layer 2 and layer 3. It will be network layer as well as data link layer, and physical comes under access layer. Now application layer, transport or host to host, anything you can call it, transport or host to host layer. It here will work. Which protocols will work? TCP, IP, and UDP. Now come to the in layer 3 and layer 2 in OSA model, but here we have layer 2, that is network layer. So in this, we'll discuss more protocol, which protocol will work here. And apart from that, physical layer comes under network access layer, or you can call it as a network layer or network internet layer. So these are the difference. Now move to, and who established it? DOD, Defense Department of Defense. We call it as a DOD model also, and it was developed by ARPANET. And OSA model, who's developed? IOS, International Organization of Standardization. Yesterday we discussed it. IOS developed OSA model. But here ARPANET, American Research Project Agency, and it was developed in 1970. And yesterday we discussed 1980 OSA model. After 10 years, before TCP/IP model came, after OSA model came. But that is the reason it's a reference model, and implementation part TCP/IP model. So it is a practical model also, you can call, or implementation also you can call it. And after implementation of protocol, this model was defined publicly. Earlier, the Department of Defense not given the publicly. After some years after they publicly they announced it. Okay, there can be 4 layers. So these are the 4 layers, and in this layer, the most important layers are this one. These 2 things we should have to know. Layer 4 as well as in layer 3 and 2. We call it as its second layer in this OSA model. It's a layer 3. So transport layer are host to host, and network layer are internet layer. And internet, in this internet layer, and we know in TCP/IP model, TCP and UDP in which layer will work. Yesterday we discussed very well. TCP, transmission control protocol, and UDP stands for user datagram protocol. And it is a 3-way handshake. It will be used 3-way handshake, and it will not reliable protocol. That is the reason it won't use anything. So now comes to the internet layer protocol, which protocol are working in this layer 2. So these are the protocols. We'll discuss each and everything in our packet flow. Why I am explaining entire thing in packet flow, with this only, without we cannot discuss anything. In fact, packet flow, everything is required. IP addressing, IPv4 will use. How I'll explain. And ICMP, when we are originating something, we'll discuss. ICMP will it will be used in this echo request, and echo response will be happen. And address resolution protocol, ARP. What is the ARP? With the help of ARP, will find out IP address to unknown MAC address, media access control. I'll explain, just wait for a while. What is MAC? And reverse ARP means unknown MAC address to will find out the IP address. Here we in this ARP we are find out the IP to MAC. Here reverse ARP means we are find out the MAC to IP address. That much only. And we have 2 types of internet protocols, IPv4 as well as IPv6, version 4 and version 6. So why we have 2 protocols means shortage of IPv4. IPv4 addresses 4.7 billions only, but in this IPv6, billions IP addresses we have, more billions. Okay, IPv6, because it's a 32-bit only, but when we are discussing IPv4, it having a IPv6 having a 128-bit. So you can calculate 128. It means 2 to the power of 128. You can calculate it. If you calculate 2 to the power of 32, you will get this with the value 4.7 billions. So ICMP provide IP provide connectionless best efforts delivery routing of datagrams. We'll discuss IP is not concerned with content of datagram. It looks for way to move the datagram to their destination. So we'll discuss in packet flow from source to destination. This is our source and our destination. How the packets are forwarding, how initiated packet will be reached to destination, we'll discuss in packet flow. So for that, we'll take best example here, ping, or apart from that, we'll take different trace route or anything you can take the example of that. So here we are taking the ping request whenever we are doing the packet internet gopher. So ping stands for packet internet gopher. So whenever we are initiating ping request, behind the ping, one ICMP protocol will work. That is Internet Control Message Protocol, ICMP. So ICMP message are carried in IP datagram and used to send error and control messages. It with the help of, if any error is occurred, then traffic will be denied. If nothing is there, any error, then packet will be perfectly, it will be moved. Behind the ICMP again, echo request and echo message will be forward. So wait, and destination is unreachable ping trace route, the following. So this is a, and address resolution protocol will find out, will resolve the MAC address to knowing IP address. Just we discussed, we unknown MAC address here will resolve. We don't know the MAC address, will resolve it. How? I'll explain. So reverse ARP means it's reverse ARP, knowing here resolve the IP address with that based on the unknown MAC address. When we discuss in DHCP, I'll explain the more on this reverse ARP. In DHCP protocol only, reverse RR will be work. Here we have two types of R address resolution protocol and RR. Two types of R. So now move to the packet flow. Before that, I'll explain you something regarding the switch. We'll discuss something about the switch details, then we'll move. What is switch, how it will be work. So switch details here, and it is a data link layer device, L2 device, and it is an intelligent device, and because switch maintains the MAC address table, so that is the reason it is an intelligent device. But switch, what it is doing, it is broadcasting the information. So what is broadcast, I'll explain. And it has one broadcast domain by default. And switch having only one broadcast domain, it means that is sufficient. So switch having multiple ports, those are the 28 you can assume. It's 24 ports and having 48 port switches also. So you can assume here we have the 48 ports. What is single broadcast domain? So here I am sitting, this is PC1, my PC, and I'm initiating some traffic for other PC. What? So sorry. So 48 ports and 24 ports by default switches having. So Here also PCs we can assume all are the connected. So by default, what I mentioned, switch having by default one broadcast domain. What is broadcast? Yesterday we discussed one to all. Unicast means one to one, and multicast means one to group of. So I initiated some traffic home PC 2, but switch once enter here, switch broadcast the information to every PC. So that is what broadcast. How it is broadcast, I'll show you in lab. So every PC, that is a single broadcast domain. It's a single broadcast domain. It is initiating to everyone traffic. So number of collision domains depend upon the number of ports. So collision means it is collision once it is sending and receiving at a time. So it is sending and receiving at a time. In this segment, one is sending and one is receiving. So switch having number of collision domains and it maintains MAC address table. So I'll show you. And switch maintain MAC address table, but router maintain MAC as well as routing table also. Routing table, switch router will maintain routing table. So now we'll move the lab. We'll check the behavior of switch. And before that, I'll give you the quick overview, the packet flow. What is the packet flow? So it's a switch, and in this switch, having multiple connectivity PCs. So here 1, 2. So I'll take 4 PCs. And this is a PC1 and first PC, second PC and third PC and fourth PC. As we discussed, every PC having the MAC address details. Say F0 by 0, 0 by 0 port number, and one more port F0 by 2, F0 by 1, and it's F0 by 2, and this port is F0 by 3. So this PC having MAC address is A, and this PC having MAC address is B, and this is C, and this one is D. So what happened? And IP address of switch 1 is 192.168.1.1, and this PC having IP address is 192.168.1.2. So without IP addresses, we cannot so if I want to communicate at the different PCs, so two things is required. One is IP address, another one is IP address.
How do you differentiate a MAC address and IP address? You said a switch, one has a IP address, 2 has a IP address, 3 has a IP address, 4 has a IP address. However, they are not, they won't work if you don't have a MAC address. So how do you differentiate that?
See, okay. Tell me, MAC address in which layer it will work? MAC addresses are work in which layer?
Layer 2.
Play.
So before that, I'll explain something related to MAC address. Then
Physical layer of OSI model.
Physical layer.
So MAC address stands for media access control, and it is a physical address also, even though yes, even though in your PC also. Wait for a while. we are differentiate. Okay. So it stands for media access control. It is a physical address and the size is 48-bit, and how we'll differentiate means the something like its broadcast address f.f.8 and fff and fff. So likewise, it's a 12 hexadecimal number. Okay. And every device by default having MAC address. Every device having the MAC address. So by default, it will be happen. So in IP address, we have two types of IP address, public as well as private. So in this, public IP addresses we should have to buy from IT, but in private IP addresses, it are the free. Those are the free. In this, we have a different classes, class A, class B, class C. Those will can use. Understood. Now, IP addresses are working in layer 3. MAC addresses are working in layer 2. If you are not speaking, if you are not asking anything, just mute on yourself because echo is coming. So it's hardware address, and in Cisco devices also every means see router also having MAC address, but switches having the MAC address every port, but router only one MAC address, but switch having its own MAC address as well as every port having different MAC address. So here this port also having different MAC address, this port also different MAC address, and this port also different MAC address, this port also different MAC address. But switch also having unique MAC address. By default, it will be get. Those are the in this also. In this 26-bit is different. Sorry. So,
Switch and MAC address will work on the same layer of OSI model.
sorry.
Switch and MAC address will work on the same layer of OSI model. I mean, switch
Yes,
works
layer
on
2. Layer
data link layer 2.
Yes.
Either
Even
though
though
the
if
switch
not only layer 2, we have a MLS switches also. It's L3 switches also. L3 switches, multi-layer switches. In this, we have to configure the IP addresses.
switch will be used to communicate with the same network address, right?
So when we are using LAN, that time we need a switch.
Yeah.
So within a network, switch will work within a network.
Yeah.
Within a network.
Within a
And
network.
router, yes. If you can ask
router
me,
will work with different
MLS switch.
yeah.
Yes, different networks. Now
Different
we'll
network
move to
addresses.
the yes. Now we'll move to the packet flow. So how the packet flow will happen? See, first this PC, which PC? PC1 initiated some traffic from whom? PC4. So he initiated some traffic. As we discussed, switch having by default, it is unicast, right? Switch having one unicast. 1-to-1 only transmission it will be happen. What I have explained your statement is right. Mirza?
Yes, 1-to-1. This it works on unicast unicast.
Oh no, it is supposed to be broadcast.
In case of device, one device will act as a sender and all the other device act as a receiver. So switch will work within the
Anudeep,
network.
are you there? Anudeep? No, no issue. So switch act as like broadcast. Good. Only one broadcast. Just now we discussed it. It is not unicast. So when it is giving reply, that time it is unicast. So before that, it is broadcast the information. Switch has broadcast and unicast. two messages will be do. So first
By default-
broadcast only.
By default, it will be broadcast.
Yes. So he initiated some traffic. Now we'll move fast. So this is a PC1 details, PC1. And first, what is my source and destination IP? What is my destination IP? What is my source IP? So source IP address is here. Tell me, which one is the source IP address? My source IP address is here.
A.
192.168.1.1.
1.1.
And what is my destination IP address?
192.168.1.4.
1.4.
So it's 1.4 is.
4.
Now tell me the MAC addresses. So what is my source MAC address? It's a layer 3 information. Actually, it's a layer 3. How we will differentiate now? Someone asked me to how we'll differentiate the L2 and L3 information. Likewise, we'll differentiate. So whenever we are configuring, so we need every device having unique IP address. We should have to give, otherwise without IP addresses, we cannot communicate. So MAC address by default, it will be get through vendor. It's physical IP address again. And give me the layer 2 details. Tell me layer 2 here. Source MAC address is A. And destination MAC address is D. But by default, this switch don't know what is the D MAC address. PC4 MAC address by default, it don't know. That time it will be broadcast the information. Broadcast the information. That is what broadcasting information. So after then, every PC is giving the reply. It's 1.4 is my not is it will be denying. This is my this is not a my IP address. This PC also denying. This is not a my IP address. And this PC is find out, yeah, this is the my IP address. That is the reason it will be give the IP. It will be give the details of this. Which details? MAC details it is giving. Which through which port? This port. So F0/3. F0/3 port will get the MAC detail of this PC. So at that time, it will be stored in MAC address table. Up to 300 seconds, it will be stored. It means 5 minutes. 5 minutes, information will be stored. In 5 minutes, the information will be stored. It's L2 information. After then, it will be given to the pack to the L1. The L1, the bit format, it will happen in this frames. The frame originated, and here we originated some packets. So in frames, what will be happen? 0, 1s are whichever the cable connectivity. Fast Ethernet 0/0, 0/0 here, and fast Ethernet 0/4 here. And this switch, whenever it is giving the reply, again that time this is giving reply, right? Here you can assume this is a source again. Which one is source? Here PC4 information. This is a PC4, and this is a destination. Who is destination now? Destination and the addresses, source addresses are will be changed. 1.4 IP address. This is the IP address of this PC source, and destination. Who is the destination? This one is the 1.1 is my destination. Now it will be already switch having MAC detail of this PC. When it is originating some broadcast message or packet, that time switch will store the MAC detail of this port, this PC, through which port this PC is getting. Based on that, it will be stored. So that is 0A, and it will be forward to 0. Not this is a whenever it is receiving, it is source, right? Source MAC address means it is D, and this one is received because it's A. Who is so based on R will work here, then physical layer. It's L1 and L2 information. This one is the L3 information. In better way, I'll show you in packet tracer. This is a packet flow, how it will be work. And but here in whenever we are using the port numbers, it means we are using application. So Telnet port will use Telnet here. Telnet is a service, we have remotely access the devices, whichever device, router or switch, whichever the devices, we can access entire thing. We can monitor, we can edit, we can changes anything through the PCs or with CLA modes through Telnet. I'll show you those things also. Anyone have any doubts? So here, by default, a router maintain the path manipulation, but switches having the unicast, right? So sorry, first time it is broadcast, and second time, till the switch having MAC detail, till 5 minutes it will be how? Till 5 minutes, 300 seconds. That time, the switches do the unicast only. Will give the reply unicast. Again, switches don't have the right routing table. Routing information, they don't have routing information, they don't have, and even though if you are trying to ping to switch this IP address also, you cannot, the ping request will be denied because switch don't know the IP address. Switch not working based on the IP addresses. Is, can you mute yourself? Switch is not working on the IP addresses. Switch is working on the based on the MAC addresses only. Media access and because of switches knows only MAC details only. Switches having MAC details address only.
How about 2 and
Else-
3? 2 and 3?
What about the 2 and 3? Yeah. If you are trying to ping, again originate, you can originate the traffic from him for 2. Then it will be give the reply. Whenever it is giving the reply, that time this port, through this port, it is store the MAC details. I'll show you very well in practical. I will show you. Till you are not
So A
storing.
gets you said A gets the response from D, and B, how if B is doing a ping, from where it is getting the response?
That is what switch, what it is doing, broadcasting the information. Because switch don't know, first time switches don't know the MAC details of this port. Switch don't know MAC details of this port. This PC MAC details, you don't know. That is the reason I don't know. What will you do? That time it is broadcasting the information. It is sending to everyone. So first time, this is PC1, and here we have a PC4. This is a PC4 and PC1. We have another PCs also 2 and 3. First time, now you tell me switch having empty MAC table, empty mind. So we originated some traffic to him. We know the IP address. We originated. Switch don't know the IP addresses. Switch don't know IP addresses because switch don't have the routing table. Here we have the only MAC table. Based on the MAC only, it will be issued how to work. That is the process. It's a LAN side. That is the reason we are using LAN side. So switch originated some traffic to him. So this person only will give the reply. So this person also will give will get that information. This person also will get that information. But these persons are denying that information. Yeah, that is not for me. That traffic is not from me. So I will not give the reply. So switch don't know, till switch don't know this MAC address, but switch know this MAC address. Then only switch store the MAC details of this table.
Do switch configure automatically, or do you have to configure the switch with all the information like the MAC
You no need to
information each
configure.
of the IP address?
No need to configure anything in switch. Till if you configure the VLANs, if you are configuring VLAN, then only you should have to configure. If you are not configuring anything in switch, just connect. By default, these ports are up. These ports are up. In router, by default, ports are down. By default, ports are down. You should have to configure. You should have to manually do no shutdown command here. But switch by default ports are up. I'll show you.
So
See,
where do we configure the MAC addresses for the switch to work in that way?
that is, you will get by default MAC addresses. See, I have taken one switch, new switch, brand new switch, we can assume. Just now it is starting. So I have given the MAC address. So you can check here. By default, it is got the MAC address. In real time also it will be get. And PCs, try to take one PC here and check the MAC address of this PC. I have given this fast Ethernet 0/0. I have given no. If you want to check in command prompt, so IP config all. You can check here. I have given two physical IP addresses. One is for Bluetooth connectivity and one is for Ethernet connectivity. I have not given anything till it is got. Yes, if you want to change, you can change it. If you want to change it, you can change it. So where we can in this physical here, just click on this. If you want to change it, yes, that should be, you can change it. Yeah, likewise. And IP address is also by default, nothing it is there. Likewise. Understood? By default,
Are we changing the MAC address and IP address in the switch or in the PC?
yeah, we are changing the IP addresses in PCs, LAN devices. And
And the
if
MAC
you want
address?
to MAC address, if you want to change here also, so we can change it, but we will, why we need to change it? No, not required. So connectivity is not done.
Have to feed the MAC switch with the MAC address or
Sorry,
how it is? Do we need to give the MAC address of the PC to switch, or switch will get the MAC address automatically
Just
when the PC
okay,
gets
hold your
connected?
just hold your patience. Okay. So everyone, please mute yourself. You don't have any questions. So just hold your patience. I'll explain in step by step. You can check. I am not giving to any pieces of MAC addresses here. So I'll take 4 pieces here. How the packet flow, then you can easily understand. This PC I am giving the IP address 192.168.1.1 and MAC address of this PC already given, that is 0.0.0.0.0.0.8. Manually we have given for our reference part. So for this PC, by default, it got the MAC address. If you don't want to change, no need to change it. IP config /all. With this command, you can verify it. This is the MAC address of this PC. Before that, I'll show you the connectivity also. So you can take any cable by default here. Automatically it will take. If you want to manually, you have to set. You want to set, then take over here straight over cable. Straight over cable. So by default, one device to another device, different devices will connect straight cable, and two same devices. When we are taking this two same devices, that time we'll use here crossover cable, this type of cable, cross cable. It will be asked always which port you have to configure likewise. So this is a cross cable and this is one the straight cable. Different devices will use straight cable and same devices will use crossover cable. Now more. Automatic I'm taking. So this PC IP address is 192.168.1.2 and the MAC address of this B will give, and this MAC address is will give C, and this MAC address will give 48-bit MAC address D will give. So IP address of this 192.168.1.3 and this PC having IP address is 192.168.1.4. Now you can check here. So we'll give the IP addresses also from here. You can select here IP config 192.168.1.1 and by default it will be take subnet mask. No need to give the any default gateway because we are not planning to enter any different networks. So switches are having only MAC address table only. 192.168.1.2. I have not given the MAC details still. Just wait. 192.168.1.3 and 192.168.1.4. See, before the packet flow, I'll explain you here how the ping originated, and before that I'll show you the MAC details. So MAC address table by default, so we'll clear. I have cleared the MAC address table. Now you can check. So MAC address table with this command, we can verify the MAC details. So no MAC entries available here. So by default, it will be happen. So when you are trying to initiate some traffic from PC1 to PC4, PC1 to PC4. So that time only the switch recognize that port is giving MAC addresses. So here also you can check the switches having the MAC details also 00D0. By default, I haven't given the any MAC details. If you want to check that details, so those are the different and MAC address table. We are getting the different MAC tables. So MAC details. So if you want to check that port MAC details, that is different. That is by default, it will be available. So interface fast Ethernet 0/1. This is the MAC address of by default it have, but this is not MAC address of this PC. That it will be different. That will be different. We'll verify that also. Just follow and listen carefully, then you will get your answer. And if you want to, so that is remotely access. That is we can give the IP address also. For that we will give the show VLAN brief. So I hope you are asking about the VLAN configuration part. So we'll give the IP address of this VLAN only. By default, VLAN 1 is available. So IP interface brief. If you want to give the IP address, then we'll give the IP address for this VLAN. So why we need to give? So we have to access this switch. That is the reason we have to give the IP address. We need to access remotely access. That time we'll give the IP address. Till if you no need to access, no need to give the IP address. By default, it will be like extension box only. By default, switches act as like extension box. If you are not doing any configuration, the by default ports are up only. You can check here. Whichever the ports I have configured, fast Ethernet 0/1, fast Ethernet 0/2, fast Ethernet 0/3, fast Ethernet 0/4. I have did any configuration? No, I haven't did. But if you try to attach some more PCs, then it will become by default, it will be up. And they will get the MAC details of the table. So show MAC address table. I hope you are getting your answer. So now till we don't have any MAC details. So now I'll initiate some traffic. Later on, we'll discuss the packet flow. Now I'm initiating some traffic. Ping 192.168. So 1.4. I'm initiating some traffic. So okay, we'll use here simulation tool and we'll initiate now traffic.
You said that switch has a unique MAC address and IP address, right? So the PC will connect to the switch MAC address, but not the IP address, because MAC address
No.
holds the IP address.
Yes. Now you are getting. See, I have initiated some traffic. So which traffic first by default it will have originate as started. So here you can check. First packet is ICMP, Internet Control Message Protocol. Behind the ping, one protocol is work. That is what ICMP. So in that IPv4 address is there. What is my source IP address? 192.168.1.1 and what is my destination IP address? 192.168.1.4. Here you can check. Whenever I originated some traffic, by default, this switch is don't know. This PC also don't know where is the MAC address. So you can check here. So before that, you can check the ARP with ARP table also. I'll forget to show you. No issue. I'll show you in this PC. So ARP minus A, we can verify no ARP table. Switch, PCs maintain ARP table, switches maintain MAC table. So with this PC originate some traffic. So that is the reason broadcast the information. So here. So now next packet. So it will be reach to switch, packet reach to switch. Switch, this is a switch device who's originating. Here you can check. This is the 0.0.0.0.a. So this PC is originated and for whom? For broadcast the information. Our packet is broadcast. Here layer 2 information. So source IP address is 1.1 and destination IP address is 1.4. So I haven't assigned the MAC address. Don't confuse here. So this PC will give the reply. Apart from that, these PCs are denied. You can check next packet. I'll forward. So every PC got that information. So now you can check. It is denying. Here you can check the cross mark also. The cross mark is giving cross mark, but it is not giving the any cross mark because he know that message is came from me. You know. Now move next packet. Now who will be give the reply? Now you can check here.
It's not receiving the two between 1 and 2. It is not receiving
Will-
the messages. So that is the reason it is giving cross mark.
Yeah, they are, but switch originated packet from them also, right? So here you can check. Switch sent to him also, and him also. So because the IP address is here for this PC, that is the reason this PC is giving the reply. Apart from that, they are denying. So switch now he know the MAC details. Now he store the MAC details. If you want to check, you can check. So this show MAC address table. So now you can check fast Ethernet 0/0. We know the MAC address of this we have given, but we haven't configured 00. That is the reason by default, whichever the MAC address of this that is taken. So that is now you got it.
Okay, the switch will broadcast.
Yeah, switch
And
will broadcast. That is what I'm
identify the
explaining.
MAC address and it will store
Yes.
it in the MAC table.
Yes, MAC table. That is what MAC
Okay.
table.
Okay. Got it.
Great.
So we don't have to separately configure. We just have to connect to switch. And whenever
Yes.
the PC gets connected to switch, it will get the MAC address and it will store it in the MAC table in the switch.
Yes. Well,
Okay,
we
Again,
have.
I had a question. Like here you can see the MAC address, which is like 12 unique number, which is like A, right? You have already given the MAC address as like D for the PC
No,
port,
I haven't given.
right?
No,
Then,
I have not given. Not given.
but
I haven't
the MAC
changed.
address, has been defined as A, right? Here
That
you
is
can see in
what.
the MAC memory. Okay.
So wait, hold.
Okay.
Hold your question. PC4, you can check verify here. IP config on.
Yeah.
So this is the MAC address. I'm copy from here. So Control C, copy, and I'll paste here. You can check. I have not changed the her MAC address. So, but you can
Okay.
check here. By default, whichever the MAC address is there, you can verify now. But see, this is the MAC address. You can verify.
Can you just show me the can you just show me the same way for the PC1 as well?
Okay, fine.
MAC
I'll
address.
show you. Okay, I'll show you. So for that, we have to complete the process. So anyway, no issue. If you are asking,
No.
then I'll show you
Why?
here.
Because when you're executing, right, that finally you're getting the MAC address as like 000, like 12 digit of A, right? So that is what the question is in the MAC memory table.
I have changed it. Wait. I'll show you. For that I have to stop the entire process. So ping request is got. So IP config.
Okay.
Alim, when PC gets connected to switch, the switch will generate a MAC address for that PC1, right? To start with, we never had a MAC address. We had only IP address. But when PC gets connected to switch, the switch will dynamically generate a MAC address for that PC1.
Yeah, with the help of ARP protocol, with the help of ARP protocol here.
ARP
Okay.
That is
protocol.
ARP protocol. With the
Oh,
ARP
okay.
protocol, unknown, which unknown MAC address to, it is find out which unknown MAC.
Okay.
With whom it is find out, knowing. We know our IP address. Knowing IP address to, it is find out the MAC details.
It's like a broadcast and routing, right? The switch does a broadcasting and routing.
No, routing is different, a totally different concept.
Okay.
Now you can check here. Here you can check. This is the MAC details of the PC Ethernet. What is the Ethernet? So here you can find out fast Ethernet 0/0, fast Ethernet 0. Whichever I have given, that is the only IP address is available here. So for your reference part, I'll change the entire MAC details. So now you can check. I have changed only one PC. Now I'll change for this PC also. We'll check. Then only you can easily understand. So
No, here for each PC, my question is that for each PC you are already giving the MAC address as like A, B, C, D, right? Okay, when you are storing into the MAC address memory, it should come as like D, right? When you're looking for an information from 1.4, then it should come the memory as like 1D, right? Then why we are getting the other MAC address as like 00902BB? So that is what my question was.
That time I haven't changed that MAC details. For your reference part, I have not changed that MAC details. I have right here, but I haven't changed.
Okay.
Now I'm changing.
Okay. Then that is fine. Okay, I got it. Okay, somehow what are the MAC address which has been there for 1.4? That is the MAC address we are getting.
See,
So
earlier
226. Okay, I can see it now. Okay, it's okay. I got it. Okay, yeah, it's fine. Alim, yeah, I got it. Thank you.
Okay, no issue.
Yeah.
Now I'll clear the MAC details.
Now we will get D.
Now no MAC address is there. Now try to initiate some traffic. Now this time I'll initiate the traffic to different PCs. Okay, we can check the different PCs also. Now, if you are initiating, so try to ping in this PC 192.168.1.1. We are getting the ping request. No, because switch don't have the MAC detail. Only switch have only MAC details, not the routing details. So you can check, and we'll do that same thing also. And I'm initiating some traffic again, same or different, your wish, different or same, different for different PC or same PC. Tell me, guys. You want to check the different?
Yeah, you can check for the 1.2 or 1.3 anything.
Okay.
Yeah.
So two packets are initiated. One is here ICMP, another one is R. So RP is FFF. So ICMP
Yeah.
packet that
Source is
source IP
1.1. Destination is
destination.
1.3. You're getting the MAC address, trying to get the information from 1.3. Okay, when
So
you
now
run it,
initiated. So now this switch don't have MAC details. Now we clear it. Now you can check
Okay.
it is so these PCs are denying because the message, the packet not come for him also. So that is the reason. So both are denying here. This PC also, this PC. But this will be give the reply. You can check next packet. Only this PC is giving the reply. Broadcast whenever the broadcast is giving also, but giving the reply that time unicast. This is a unicast. 1 to 1 is giving. 1 to 1 only giving the unicast. But switch what it is doing, broadcasting information, that is what single broadcast. Okay, fine.
Yeah.
So the PC got, and again it is giving the reply. And now this PC got the MAC details. So you can check. Earlier, this PC don't have the MAC details.
Yeah.
That time it is the ARP table. F, it will be happen when the packets are not giving the reply. Till that time it will be FFF only. Once it will be originate, see here you can check. This not for this PC, even though this PC originate traffic from him also 2 or 3. This is a PC2, 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 and see PC. Oh, sorry, here switch. This is a switch PC2 and 3, and this is a 4. And but PC2 only giving the reply. Here you can check. 0 as in this MAC address is there. This PC only giving the reply. And finally, we
Where
got
we are initiating? Are we initiating from PC2 or PC1?
so
PC
from here
2
to here to 3.
from PC 1 to 3.
So you can check source and destination. You can check from here also. So this is the source IP address is 192.168.1.1. So this is the destination. This is a packet replying, giving the reply. And here, this is the source 192.168.1.1 and 192.168.1.3. Whenever it is
Again,
giving
it
the
is.
reply, that time it will be change the IP address. You can check here.
Okay.
But
Yeah.
this is
It
a
cannot be
layer
PC2 to PC3. We cannot initiate from PC2 to PC1, PC2 to PC3.
Yes, we can
PC2
initiate.
to PC.
Yes, we can initiate it. Till the MAC address, you can check. That is the reason I'm showing one by one. So till we got two MAC addresses only. Now you can initiate some different traffic. Once we'll do the same thing. So,
It's like
Try from
coordinate
2 to
1
4.
1. It's like coordinates like 1 1 1 2 1 3 1 4 2 1 2 2 2 3 2 4 like that. We do like that, right? All combinations.
no, whichever you want to give, you can change it. No issue.
Okay.
Just for reference part, I'm giving here. Just for your understanding part, I'm giving.
So
Just
let's say
changing
from
the source
if
and
we send
destination.
the
So here
source
you
and
can check.
destinations, if we choose the PC2 and the PC4, then you will get a whole MAC addresses because
Yes. Now got it, but till we have not a this MAC address because we are not initiated anything for him. So once you will initiate some traffic, then only he will give the reply that whenever the switch give the getting the reply from this PC, that time only it will be recognized. Ah, okay, this is the PC to MAC address. Then it will be stored till 5 minutes. Till 5 minutes it will be stored. Up to that, the unicast message only flooding. So that is 300 seconds actually, 300 seconds. This MAC table will be 300 seconds. So we'll initiate the traffic again. From before that, we'll check in ARP table. In PCs, we'll maintain ARP table, ARP minus A. So we got two MAC details in this PC. You can verify it. In real time, this is a useful command. It's a useful command. Now we'll initiate the traffic for 2 also. So we got a request. So now you can check ARP minus A. So now you can check the 3 MAC details. Now, whichever we have changed, that MAC addresses only we are getting. Now you got it. If you are not changing, by default, whichever the MAC address is available for this PC, that PC MAC address will get. Now you can check. I'll take one more PC. I'm not changing anything, but I'll give the IP address for this PC 192.168.1.5. Now give the IP address on desktop and move to here and give the IP address 192.168.1.5. And I have not changed the MAC details. Don't confuse here. So now check. Try to ping 192.168.1.5. First packet will be dropped because of ARP table. But though whichever the ARP ping request and ping reply, it will be 2 seconds only. Within a 2 seconds, the reply will not get, the packet will be dropped here. That is what it will be take time. So broadcasting, right? It will be take minimum 2 seconds. It is broadcasting. When he don't know the MAC details of this port, that is the reason it is broadcasting. So that is the time is 2 seconds. First packet, that is the reason drop, but 3 packets we got. So here you can check time to live. So this is the time to live means this many hops. 128 and Cisco Windows having 128 and Cisco devices, Microsoft having the 128 and Cisco devices having the 255 and Linux devices having here TTL values 64 different values. Don't confuse whenever you see in real time. So now you can check ARP table minus A. So this is, you can verify the MAC address is different because I haven't configured. This is all about packet flow. Anyone have any questions?
One more
Understood.
thing, why the IP address, why we are configuration only in IP4? Why we are not using the IPv6? Do you have any reason on that when we are giving the IP address for each PC?
So see, in real time, what
Mhm.
happened? We have, as I mentioned, we have 2 types of IP addresses, public and one
And
more
private.
is private.
Okay.
In
Okay.
this private range only, again, it's a 32-bit of IP addresses. So
Okay.
the concept is came here. So limitation of IP address 4.7 billion something we will get IP addresses on
Okay.
this total public and private IP addresses. This many IP addresses. That is the reason
Mhm.
we get some subnet concept. The subnet, what it will be do with the help of subnetting. So we have class A some range, class B, class C, and class A, class B, and class C. We have range. In this class A range, total series 10.0.0.0.0. In this only you will getting the lakhs of IP addresses. And in this 172 dot and 16 dot from starting from 0 to 02 and 172 dot 31.255.255 up to this many IP addresses and 192 class C 192.168.0.02 and up to 192.168.255.255. This much range you are getting. So these all are the free of cost. So nowadays every old switches and old PCs nowadays new versions can understand IPv4 also and IPv6 also. Both they can understand. So some organizations also work, so some organizations only like GO, this is a big kind of organization, those kind of organizations only working on IPv4 as well as IPv6. So if small kind of organizations, they are working IPv4 only because they are getting the lakhs of IP addresses that also free of cost. So that we have a NAT concept also. Based on this NAT concept, what it will be do? It will be convert your private. This is a private free of cost. Why I have to use headache on this IPv6? So I can use still private IP to public IP NAT conversion. NAT, what it will be do? It will be convert our private to public. We have a concept here.
Converting
We'll
the
discuss NATing. Yes.
private IP
convert-
addresses into the public, so everyone is using the public addresses, so that it's a free of cost or something like that.
Yes, yes. Here in
Instead
this
of
NAT
having,
also.
okay,
Yes.
okay.
Good.
Okay, got it. Thank you all. Yeah.
Okay, welcome. Fine. And we'll move. So second lab we'll do. I'll open new lab. Cisco packet tracer, and we'll take a remotely how we'll access with the use of Telnet. What is Telnet means? Telnet is a service. We have a Telnet. We have a service here, Telnet service. With that Telnet service, we can access any device remotely. We can access it, even though switch or even though your PC. So, based on your PC, we can access remotely from different location. If you want to access remotely for this switch, we have a Telnet concept. Based on the Telnet concept, we can access from remotely or physically also. So based on, for that we have a putty software in real time. I'm showing you here real time. We have a Telnet option. By default, it will be used. The Telnet is 23 port number. You can check here. Telnet using the 23 port number. So we'll discuss based only from brief about the Telnet here. So just to give the IP address something, you can access directly. Before that, you should have to connect likewise. Physically, we have a one console port. In switches also, we have one console port. Will get here also. You can check is a physical view. In these ports, you'll get, you see here you can get the console port. Here you can check see console port. Just connect to your PC. Otherwise, nowadays smart ports also came. It's USB port. It's a USB port, or C-type ports also we have. Type C port also we have. Through that we can smart cables also, smart consoles also came nowadays. So that is what we can access through CLI command. So this access. So for that I'll give configuration here, and we'll check the traffic flow also. For config terminal, and so by default, we don't have IP address. Now, Naveen, here you can check how I am giving the IP address. So by default, we have VLAN 1. So VLAN brief, you can check. We have the VLAN 1 is by default, and this many VLANs we have. Anyway, we'll discuss later on VLAN sections, but just hold how I am giving, just check it. So show IP interface brief. In this, we don't have IP address. By default, it is down. By default, it is down. Administrative down. Even though if you are assigning the IP address also, the interfaces are up, but these ports are down. By default, VLANs are down. We should have to make on this, particularly VLAN 1, not other VLANs. So config terminal interface VLAN 1, and I am giving the IP address for this 192.168.1.1, and subnet mask 255.255.255.0, and that much only. Exit. And no, wait, I have just given the IP address. You can check. Still it is down only, administratively down. I have not used here the command, but this port is up. This port is up, fast Ethernet 0/1. Just wait, don't confuse it. Just I am explaining the packet flow here. Interface VLAN 1 and no shutdown. Just use this command and give to interface fast Ethernet 0/0. So what I am doing, don't confuse it. I am some little bit configuration I have to do. So switch port mode access and switch port access VLAN 1. If you don't know also, we'll discuss later on this. This is a concept is different.
What is the regular when you are using port and a normal port and a telnet port are two different things? They are all ports.
Yeah,
What is the
telnet port and
regular port, normal port, right? Switch. You just said the telnet port. Before that, we are
yeah,
using
yes,
a normal port.
yeah, here I am using the normal port. This is a lab part, but whenever you are trying to configure, you should have to use this is the console port. That is what I have explained here. This is a console port. You have to connect for this port to your RJ45 in your laptop available. If RJ45 in not available, nowadays smart cables also came. Type C or USB cables also is there. In your laptop, definitely USB port also is there.
When we say,
Otherwise, C port.
when we say console port means it's a telnet. When we say console port, is a telnet.
Guys, if you want to access this device remotely from any other remotely, or if you want to access through CLI, this is a CLI. If I want to change configuration here, so I cannot configure directly, right? We need some PC. In first time, whenever in real time you are configuring this PC, the switches don't have monitor, right? Switches having monitor or not? Switches don't have any monitor. These switches have monitor? They don't have. So you need a one service because you need to configure something on switch. You need to change something configuration or anything. So how you will configure it in real time? ఇక్కడ ఏదైనా కన్ఫిగరేషన్ చేంజ్ చేయాలనుకోండి, ఏదైనా కన్ఫిగరేషన్ చేంజ్ చేయాలనుకోండి, దానికి సిస్టానికి మానిటర్ ఉంటుందా बाय डिफॉल्ट? इसको मॉनिटर रहता क्या?
नहीं रहता।
नहीं रहता तो तुम क्या करना चाहिए? इसको मॉनिटर करने के वास्ते इसको कुछ चेंजेस करना है तुम्हारे को, तो तुम्हारे को एक पीसी से कनेक्ट करना ना।
यस करेक्ट।
हाँ, तो कनेक्ट करने के लिए तुम्हारे पास ये कंसोल पोर्ट है, रियल टाइम में कंसोल पोर्ट। बट मैं लैब के पास थे, मैं ये F0/1 पोर्ट लिया है। आप लेना चाह रहे तो एक कंसोल भी ले सकते, बट अपन बाद में करेंगे वो लैब्स। अब वो उसके लिए डिफरेंट कॉन्सेप्ट पूरा देखना पड़ता। हाँ, फॉर सिंपल पैकेट फ्लो करने के वास्ते मैं कर रहा था।
थैंक यू।
Okay, now I have configured, so later on we'll discuss. So now you can check show IP interface brief. So now give the IP address for this PC also, because in between we should have to make a communication in between. For this PC I am giving the different IP address, that is 192.168.1.10. 192.168.1.10. So now try to ping that 1.1. This is the IP address of 1.1. This PC having 1.1. Can change 192.168.1.1. From here I am trying to ping 192.168.1.1. First packet will be dropped. So we are getting the ping reply. Now we'll configure the telnet configuration. So config terminal. So line VTY 024. Later on we'll discuss entire thing. What is line VTY, why we are configuring. So otherwise you can give the question mark. This many line protocols, line numbers you can access, means 1 to 15 members can access. So 0 means calculated 1, and 4 means whenever I am giving 0, 1, 2, 3, 4, 5, this many pieces also can access for him. This PC, this PC, this PC also. Whenever I am increasing the number, that many pieces can access. That is what line we leave it. And it's a then we'll give the some password. Password is Cisco, and we'll give transport is input and telnet service will enable. And to login local. That much only for client VTV configuration. So here I have to give the enable password or something. Before that, I'll give the username, that is admin, and password for this Cisco, and enable password is Cisco. So password is Cisco. So why I have given, you can understand easily. I have to access remotely for this device. So once I'll access this device, then we'll discuss the packet flow. Telnet in real time also we'll do the same thing. 192.168.1.1. So here I have given the username is admin and password is Cisco. So and enable password is from where I am using accessing this device, from where in this PC. And this is a PC, you can check here. It's a PC desktop through I am accessing. So running configuration, entire thing I can change. If you want to check anything, we can access entire thing in real time. Also we'll do the same thing here likewise only. So this is how we'll configure the LAN. Now I'll clear the MAC details. Clear MAC address table. Now show MAC address table. No MAC address table. So now we'll check. We'll initiate some traffic. Now exit from here. So this command we can exit easily. And now again we'll clear. Now we got a MAC address, so we have to clear it. Show MAC details. No MAC details is there. So simultaneously open and we'll check the packet flow of L4 also. L4 packet flow I'm showing you. So I'll initiate the ping request or telnet request. Telnet. So now you can check again the PC initiated some traffic that is for L4, that is here. You can check source port number is 1026 randomly initiated, but destination is 23. That is destination is telnet. The destination is here telnet, but source port number is he taken the random port number here. This is what L4 information. Source and destination. So 23, it is a port number. So source port number is 1026. Where it is configured, telnet and destination site, it is configured 23. He know the service, this PC knows the service which I have to enable. That is the reason he initiated. So Now you can check layer 3 information. Source IP address is 192.168.1.10 and destination IP address is 192.168.1.1 and frame Ethernet. No, so by default it got the MAC address. Not likewise. It once first time it whenever it is initiating. So here the PC store when first time if we are initiating means not likewise broadcast the information. If it will we get. But so even though we got here. So now you can check the second packet. So this PC is now giving the reply. So three-way handshake will be happen here also TCP because TCP transmission control protocol. This is a transmission control protocol. Telnet is a transmission control protocol based it will be work. Telnet. Okay. And here you can check the source port number. This is this PC initiated message and this switch is giving reply now. This switch is giving reply in that source port number is 23 and destination port number is 102. Session is created here. Session is created and in that layer 3 the information this one and layer 2 the MAC address is this one is the information. This is all about the L3 and L3 and L4 and L2 information. This is a packet flow how it will be work. So this is the TCP IP model. It's an implementation model. That is what I trying to explain entire thing. Guys, if you have any questions, then ask me.